So welcome to another segment of our videos as we continue to look at earth geometry in mathematics. So this is another sample question from an ECZ examination question paper. So I want to teach you another concept on how to calculate the speed. So it says in the diagram below, AB are points on latitude 60 degrees north, while C is a point on 60 degrees south. So you can see when you talk about the point AB are points on latitude. So AB, they are on 60 degrees north, and C, while C and D, possibly there I forgot, C and D are points on 60 degrees south, as you can see. Then A and D are lying on the longitude there, that is north and that is south. A and D are lying on the longitude 60 degrees west, and B and C are lying on the longitude 60 degrees east. Then the question there says that calculate the distance BC along the latitude 60 degrees east. So sorry, that should have been calculate the distance BC along the longitude, not latitude, but along the longitude. So along the longitude. So along the longitude. So remember, they want us to calculate along the longitude 60 degrees to the east. So remember, distance, when you're calculating distance, which is BC along the longitude, we said it's theta over 360 degrees multiplied by just 2 pi, the radius of the earth. Remember what our theta is? It is the difference in latitude between the latitude where B and C are lying. So the difference in latitude, so that is what we called as being the difference in latitude. I hope you remember that. So what is the difference in latitude? Latitude B is lying on the latitude 60 degrees north and C is on the latitude 60 degrees south. If 2 points are on different sides of the Greenwich meridian or equator, what do we need to do? We simply need to add them. So that is going to be 60 plus 60. So theta is going to give me 120 degrees. So therefore, what we need to do now is simply to replace in the formula. So the distance BC will be, what's the difference in latitude? It's 120 degrees over 360 degrees multiplied by 2. Remember our pi, they have given us that we use 3.142, and because they want you to find in nautical miles, they have given you the radius in nautical miles, which is 37 in nautical miles. So therefore, the distance BC, please, you can work it out on the calculator. So if you work it out on the calculator there, it is going to be 120 over 360 multiplied by 2 times 3.142 multiplied by 37. So it is giving me, in this case, the value that I'm getting there is simply 7,199. I'll leave it to 2 decimal places, so that would be 37 in nautical miles. Now, of course, this one can simply be left to 3 significant figures. It will be difficult, so the easiest is actually leaving it to 2 decimal places, because let me show you why I'm saying that is difficult. So 1, 2, 3, you look at the number again, you round off, put a 1 there to be 10. You can't write 10, so you bring it there. So it will be just 7,072. Remember these values that you have replaced before the decimal places, put up the zeros to maintain the place value. So it's 7,200 nautical miles. So that is the distance that they wanted us to calculate there. I hope we are together. Then the B part there, the B part question says, let's address the B part question there. It says a ship sails from C to D in 12 hours. So it sails from C to D in 12 hours. So they have told us it moves from C to D in what time? That is in 12 hours. Find its speed in knots. So they want us to find its speed in knots. Now basically, let me give you some ideas that you need to remember. Speed is equal to distance divided by time. In most cases, the distance may be in kilometers and the time may be in hours. So that will give us, when you combine, our speed will be in kilometers per hour. But sometimes speed can simply be given in nautical miles. If your distance is in nautical miles, so speed is distance over time. So if your distance is in nautical miles and your time is in hours, that will give you what we call as being nautical mile per hour. So this nautical mile per hour is the same as the knot. So we can say 1 nautical mile per hour is what is given as 1 knot. So you don't need to, to confuse that. So meaning, if they want you to give your speed in knots, it means that they want your distance to be nautical miles and your time to be in hours. That is what it simply means there. So therefore, let's calculate first of all what is the distance between C and D. Remember, because it is in nautical miles, what I told you, you can either use the simple formula or you can use the longer one. There's no problem. So let me just use the actual one. So the distance CD will be equal to theta over 360 multiplied degrees multiplied by 2 pi r then cos of x. Do you remember what the theta represents when you're finding distance along the latitude? Well, theta is representing the difference in longitude, and x is the angle of latitude, so where the 2 points are there. So what is that going to give us there? So my theta, in this case, when you look at it, C is on the longitude 60 degrees east and D is on the longitude 60 degrees west. So on different side of the Greenwich meridian we add. So 60 plus 60. So my theta will give me 120. And what is x? The latitude on which they align, it is 60 degrees. So we substitute. It will be 120 over 360 multiplied by 2 times 3.142 multiplied by 37. Allow me to clear that one. I'll put it on top there. That is 60, my x there, multiplied by cos of x, which is 60 degrees. So please, you can work out and reduce this mathematical problem to be 120 over 360 multiplied by 2 times 3.142 times 37 multiplied by cos 60. So what is that going to give us? It is giving me a 3,599.68. that is to 2 decimal places, but of course I can leave it to to a whole number. It is going to be to 2 decimal places. That would be 3600 in nautical miles. Now remember what I told you. If you didn't want to go this way, I would have alternatively calculated the distance CD by applying that formula, theta multiplied by 60 then cos x degree. As long as it is in nautical, you are calculating your distance in nautical miles. So theta, notice the theta we got there is 120 times 60 multiplied by cos of 60 degrees. If you multiply that on your calculator, that is a 120 multiplied by that is 60 multiplied by 60 multiplied by cos 60 degrees. There I'm getting a 3,600 nautical miles. So you can see that that is the same. Now once you calculate your distance, there, remember the question says find its speed in knots. So they want us to find the speed in knots. So for us to find the speed in knots, it simply means that, remember, speed is equal to distance divided by time. So speed is equal to, what's the distance? It is 3,600 in nautical miles. And what was the time? They told us it was in 12 hours. Our T is simply 12 hours. So divide by 12 hours. So S is equal to, if you divide that by 12 hours, which you can easily do, that will give us 300 nautical miles per hour. Therefore, I can simply say speed is equal to 300 knots. Remember, the nautical miles per hour and the knots are just the same. So this is the way you can go about it if you are told to calculate the speed in nautical miles. So you need to know the distance and divided by the time. That is what you need to remember. Thank you so much for watching. Watch out for more videos as I try to show you how to find now the length of a circle of latitude.